All right, so today is going to be a memory diagram example with trees. We're going to build a tree and then do a traversal. But before we get into that, does anybody have questions, any outstanding questions about the course or not about the course, about anything before we get into it? Last lecture took me up on the software and asked a bunch of good questions, so I want to give you all the same opportunity. Which we might not get any good questions. There are a few things I want to talk about. So the big thing for some of you and a negligent thing for most of you, today is the resignation deadline. So if you have any questions about grading, recovery opportunities, anything that will help inform your decision that you have to make by midnight tonight, I'd be happy to answer those questions. If not, the other section was really concerned about this stuff, but if not, whatever, I'll just go on. I have a little bit that I do want to talk about. So just an overview of where we're at with the homework. With linked lists, just a recap of kind of how LO3 has gone. With linked lists, everything that you needed for task 1, I covered on Monday, like technically everything you needed, but it might be a little tough to do the task right after the first lecture. We spent two more lectures just reinforcing linked lists and talking about them, helping you further understand how linked lists work. And we're doing the same thing with trees this week. You need everything you needed to be able to do task 1 of the homework we talked about on Monday's lecture. In Monday's lecture, that's everything that you needed to know. And then we talked about binary search trees last time, partly as a way to get more experience with trees, but partly the same reason I talk about stacks and queues. Interviewers like to ask about binary search trees. Like, it's a pretty common topic, and it's something you'll see again in 250. This is a pretty big topic in computer science. It's a fundamental topic. But I don't ask you to code it on task 2. But binary search trees can come up in the quiz. They can come up on the interview. So it was important to talk about these just within 116 as well. But no binary search trees on the project, on task 2 of the project. Same with today's lecture. Today's lecture is a memory diagram with trees, just to get you used to seeing a memory diagram with trees and some tree recursion and what that looks like on the stack and heap. That's going to help you with the quiz. The LO3 quiz, that's what this is all about, is showing you all that information. But task 2 of the homework you could do after Monday. Graphs, a little bit different. I need 2 lectures to get through everything that you need for the homework. And task 3, one of the questions, I thought it was a pretty good question from the other section, good enough that I'll answer it here, is how hard do I think task 3 is on project 3? Task 3 is more difficult than task 2 of project 3, of course, but that's one of the easier ones. I think task 3 of project 3 isn't too bad, and the main reason for that, it's pretty complex, don't get me wrong, but I don't think it's too bad because in this lecture next Wednesday, I pretty much tell you how to do task 3. I walk through conceptually how to do the task. I just don't show you code of how to do it. So your job is to take what I showed in lecture, where I pretty much go step by step and I give huge hints like you want to use this data structure here to represent this information, and your job is to take my words and just type them for the most part. But in the past, students have struggled with this task. So at some point, there's a disconnect between me and at least a subset of the students. So looks like it's a little bit harder than I do think that it is. So take that for what it's worth. After the task, you can tell me and let me know, if you can see where that disconnect is. I'd love to hear it so I can fix it for future semesters. But I think it's pretty straightforward. My guess is students struggle with task 3 only because it's so late in the semester that we're all just so burned out at that point that you got nothing left in the tank by the time you get to task 3. That was with 4 learning objectives, so cutting it down to 3, maybe that won't be as big of a problem. And then graph examples. This is just going to reinforce your understanding of graphs and just help you out. For the task 3, the interview, and the quiz. Then we got fall break. Woo! I canceled Monday. We'll get a whole week because the university should cancel Monday and Tuesday. I don't know why they don't give us a full week. No lab, no class. By default, no office hours. If some TAs want to hold office hours Monday or Tuesday, I'm not going to stop them. But by default, you shouldn't expect office hours as well this week. This week, just like the fake break earlier in the semester, I treat this as a void in the schedule, which means if you need a recovery opportunity for task 1 of project 3, for one recovery opportunity, you will get a 2-week extension. It's a 1-week extension according to the class, but since this week doesn't exist, it goes all the way to this Wednesday, all the way up to the Project 2 task deadline. Same thing if you need a second recovery opportunity for Project 2 task 3, that'll be a 2-week extension for 1 RO. I treat this as just like it doesn't exist. The reason for that is I want to encourage you to actually take a break. Just relax. Don't think about 116 for a week. 116 is going to, we'll be here when you get back, but you're not going to have a recovery opportunity that makes something due in the middle of break. Doesn't make sense to me. Then LO3, the quiz and interview work a little bit differently because I run out of weeks in the schedule. When I plan out the schedule, I realize I don't have another week for review. So the first chance and the second chance are back-to-back weeks. And then the review lab, you would normally have a review lab in between where you'd see the solutions to the quiz. That instead will happen in lecture. So on the last week of class, Monday, I'm going to go over quiz solutions for LO3. And then we have 2 days of review. For these, I usually put a post on Piazza where you can tell me what to do these weeks, these 2 lectures, whatever y'all want to see. I don't have any specific review. I used to do review of the whole course during these review days. For whatever reason, students just never liked that. I don't know why. Probably because I have optional final exams, so it's not getting you ready for the final or anything. So I leave those up to a vote. Whatever popular vote says, that's what I do. And right after break, a week of LO3 review, just like we did for LO1 and LO2, a week of just examples, a week to catch our breaths without new material to help you out through learning objective 3. The new news, so most of that's just me reading the schedule to you, boring. But the new news here is after break, I'm not going to have any more lecture questions. So these 6 lectures after break will not have lecture questions. The last lecture question of the semester will be next Friday. So however that factors into any decisions you're going to make, you can make those decisions more informed now. I don't care what you do with that information, but just letting you know that's what it is. Because I don't have any new material after next Wednesday, there's no reason to have the lecture questions anymore. You are already here for everything that you need to know. If you don't need these examples and this extra help, you can make your own decision for that. We still don't get to see codes for projects we did so far, even at the end of the semester. Not necessarily. Just vote for it. I'll do whatever you want on these. If you want me to go over homework solutions, I'll go over homework solutions. This course, some of you may have heard, this course is switching to Java next semester. This is the last semester of Scala, so whether it's good or bad, you either missed it or lucked out by 1 semester. So I can't reuse these assignments anyway. So I'll give away solutions to anything that's not still out. So I won't go over Project 3 solutions because people with recovery opportunities will still be doing homework 3, but I'll go over anything else. You like to compare with your code? Yeah, I can do that. Yeah, as long as it gets voted for, I'll do that in one of these 2 lectures or both. If you want to see homework 1 solutions, homework 2 solutions, I have no problem with that. It's got to get voted. I'll do that. So I'll make a Piazza post for those 2 lectures. Probably when we get back from break, I'll make that post. And then you comment on that post, vote on comments, and the 2 things that get the most votes, at the very least, I'll cover those. If I have time, I'll cover 3 or 4, Depends what the suggestions are. So if your classmates agree that they also want to see that, post it on that post when it comes and vote. Hey, anything else? Yes. Yes, you can. The final exam structure, it's going to look just like the quizzes. You're going to feel like we took the 3 lab quizzes, stapled them together, and handed them to you. That's what it's going to look like. The only difference is we will print them out. We will actually hand you an exam. So they'll be printed out, and then you'll do it on paper instead of trying to put, I don't even know how we would do it. Put it on the projector. I'm not going to have everybody have laptops open during the final.
So they're all like memory diagrams?
Yep, all memory diagrams. So for the final exam, and I'll expand on this a little bit just because that is coming up. On the final exam, if you took the first chance quiz, all 3 first chance quizzes, and got all 3 application objectives on all 3 quizzes, I should not see you at the final exam. There's no reason for you to be there. If you want to come just to say hi or get some extra practice, fine. Some students do that, and that's fine. I do mean fine. I didn't mean that sarcastically. But there's no reason for you to be there according to your grade. Your grade will not improve. The final exam is only about application objectives, so it's only for the application objectives that you could have earned on the first chance quizzes. So nobody fails by not going to the final exam, and nobody can pass by going to the final exam. It does not make any difference to your pass-fail status in this class. It's only to improve your grade if you miss those chances on the first chance quizzes. You can take the final exam and make up those application objectives no matter what. It's not conditional at all. Somebody in the other section asked this, if they needed a recovery opportunity and 3 chances to get through the LO1 quiz, can they still take the final exam and get the application objective? Yes, absolutely. There are some students who took the first quiz, the LO1 quiz, 4 times. They used 2 recovery opportunities, took 4 chances to get through the learning objective portion of that quiz. If they still want to show up to the final and prove that they've learned the content and earn that application objective, absolutely. You're more than that's the goal of the final exam, is to allow you to do that. That's the whole purpose of the final exam. So if you really struggled, say you really struggled on LO1, LO2 quizzes, you did need recovery opportunities, you took them multiple times, you just weren't getting it. Finally got it, it clicked, you understand it, and then you walk into the final exam and you're like, look, I know I struggled earlier in the semester, these concepts just didn't hit me right, but now I've studied, I understand this stuff, I know my stuff. The final exam is there for you to prove yourself and say, look, you deserve a better grade. Here are the application objectives that you missed earlier. Take the application objectives and get a better grade. Prove to me that you know your stuff. Because in some aspects, I can't design a course entirely around this. I've tried. But what I care about is what you know at the end of the semester. I don't care how long it took you to get there. I care what you know at the end. If you know your stuff by the end of the semester, I want to give you the grade that you deserve. It's not always feasible. I do have deadlines and such. I try to give you extensions and things with these recovery opportunities, but I can only go so far with that. But the application objectives on the quizzes, that's one thing where I definitely can give you all the way to the end of the semester to prove yourself. By the way, and we'll have plenty of time to go through the slides. I planned a long intro today. But just a quick side note, one semester, I only made this mistake once. I went whole hog on that. I said, you know what, I only care what students know at the end of the semester. Everything due last day of classes. Manage your own time, figure it out, but I only care what you know at the end. You can probably predict how that happened. I like that in spirit. I don't want to force you to do anything at a particular time, but half the class failed, which is awful. I don't like failing so many students. So now I have all these little things, lecture questions, expected deadlines, actual deadline. I have all that crap because I don't want to see half of you fail. It is an unfortunate reality that I can't go whole hog on that and say, prove to me by the end of the semester that you learned all this stuff. But I try to split the difference with recovery opportunities and extensions and things like that. But Are we allowed to do a segment of the final? Yes. So if you say you got AO2 and AO3 on the quizzes, but you just missed AO1 on the first quiz, only do the first section of the final exam. You don't need to do the second and third sections. Last semester, I don't think we'll do it again this semester because it was a pain in the ass logistically, but last semester we printed your name on the exam and we only printed the ones that you needed. So you wouldn't even get the whole exam, you would just get the ones that you needed. We may or may not do that again this semester. There's just so much work to set up. But I mean, if a TA wants to set it up, they can. I'm not going to because I don't want to do that. What's that? Wait.
Make that an application objective.
Oh, yeah.
Logistics of the entire class.
Yeah, if you print out the exams for the class, they'll give you an AO. Maybe. Maybe. No, I can't actually do that. There's FERPA reasons that I can't do that. I do like the idea, though. Yeah, even if you miss, so even if you needed to, like it's unconditional. If you slept through lab for chance 1 and 2 of a quiz, you missed the email for the TAs scheduling the third round, and then you had to take the fourth round using 2 recovery opportunities, you can still go to the final exam and make that up. I don't care what your situation is. If you have the learning objectives, you're passing the class going into the final exam, earn your AOs and improve that grade. I don't care how you got there, as long as you got there. And yeah, only the parts that you missed, the AOs that you missed. If you earned the application objective on the quiz for learning objectives 2 and 3, and you don't, this is the same question like 4 times. Okay, we get it. What determines if you get an AO or not on the quiz? If you really did well on it, there's no like hard and fast. This is how you get it, but if you really knew your stuff. So if you got everything perfect on the quiz, obviously you get the AO. That's an easy decision. If you didn't get anything perfect, then we have to decide, are your mistakes significant enough that you don't fully and completely understand what's going on with this content? That's the decision we have to make for the AO. So if it's like a clear just typo that you know your stuff, but you just wrote down the wrong number, that's easy. We can still give you the AO, but it's at some point the mistake is bad enough. If you're missing an entire stack frame, you're probably not getting the AO, for example. But it is judgment calls. We make those judgment calls consistently across the board, but there's so many different little mistakes that can be made that we have to make those calls separately. No shot, you can send me an email about that one. There was a case where, like if that's the only thing that you did, I can take a look at that one. I am allowed to override the TA's grading. So if it is something that you really feel like you understand the material and you demonstrated that well on the quiz and you made a little mistake and you missed the AO because of that, you can always petition that to me. You can always argue to me and say, hey, I think this is a minor mistake. And if you have a convincing argument, I'll give you the point. If I got 2 questions perfect and a minor mistake on the third question, can I still get the AO? It depends on the minor mistake. It all depends. Yeah, if you disagree with the grading, I mean, at risk of getting 100 emails today, I'll make that offer. But if you disagree with the grading, send me an email or come to office hours. I'll take a look. But it depends how minor. A mistake on question 3. So for the first quiz, there's 3 questions. The first 2 are pretty straightforward. It's, did you pay attention at all in class? Like, do you understand how to make a stack frame, to make a code block, things like that. And then question 3 was where we're like, okay, earn your AO on question 3. So a mistake on question 3 usually knocked you out of the AO. But if it is extremely minor, but really the grading for round 1, for LO1 was the first 2 questions are your LO, your third question is your AO. So a mistake on question 3 could knock you out of the AO pretty easily. Just depends on what the mistake was. If the mistake was, I don't know, I don't have an example off the top of my head, but I can take a look. Also, those of you, if there's anyone in the room still trying to make that decision for resigning or not, send me an email about that. I can let you know. Some of you know this. I can be pretty slow with email at times, but when there's a big deadline coming up, I like to clear out my inbox and make sure I respond to everybody. So this morning I was responding to a lot of students, the panic emails of, I'm going to fail the class, should I resign or not? I want to make sure I respond to you before the resignation deadline. So if you are on that fence and trying to decide, let me know. And I want to see you pass. Usually for those, I'll help you out a little bit in terms of giving a little bit of leniency. If it's a pass-fail, like a life or death, do or die situation, I want to help you out and push you towards passing. But all right, with all that, I think we had a 20-minute intro in the other lecture, so I know we can still get through this, but we do got to start getting through some slides. Read this. So, yeah, and I'm a lot more patient these days than I used to be, but yeah, most of these questions are in the syllabus. Like, I don't really have to answer these. But yes, you can use recovery opportunities on the LO3 interviews. So grading-wise, like, we have to rush the grading on the round 2 LO3 interviews. And then round 3 for LO3 usually goes directly to me. There's no round where the TAs are scheduling interviews with you. I think that's what we've done in the past. Just because it's got to happen quick, I want to get that done and get everything in without an extra layer of logistics. But we'll get them done. If you got 4 recovery opportunities left and you failed the LO3 quiz and or interview twice, I'm going to give you those 4 extra chances if needed. Like, we'll get it done. That's on me to handle the logistics of that. You don't have to worry about that. If you don't pass that and you got recovery opportunities, you have every right to use those recovery opportunities. The only exception to that is deadline extensions on tasks. I'm not going to extend a deadline after the Wednesday during finals week. So even if you have recovery opportunities left, if you don't finish the homework, all the tasks, all 9 tasks by that Wednesday, doesn't matter how many recovery opportunities you have left. Now, that's another case where if that's the only thing you need in the class, you're going to send me an email and I'm going to say, okay, I gave you a 2-day extension, get this shit done so you can pass the class. Like, that's what's going to happen realistically. But you can't just keep using recovery opportunities until the new year. We can't do that. I just can't do that because I got final grades due. All right, let's get into it. We're going to do this program in a memory diagram. I'm going to create a tree. I'm going to do a post-order traversal on that tree to visit every node. For the first parts, we've seen probably at least 20 times creating an object. We're going to call the constructor, create the object on the heap, return a reference. So I'm going to go through creating this tree pretty quickly and just focus on the tree-specific content. But I assume that first line, new BT node of day null null, and assign that to a variable type root. I assume you can all do this by this point. If not, review some LO2 material. Or ask questions. I'd be happy to answer those questions right now. Yeah, I used to not answer any questions about the syllabus. I'd just be like, read the syllabus. I was one of those professors. I've toned back on that. I'll answer syllabus questions depending on my mood. I'm in a pretty good mood today, so I'll answer all kinds of questions today. And I left off my types and my type parameters here. I am using type inference here. For most of the semester, I don't like to do this. I like to be extremely clear on my types. But one, if I added my type right here, this would be pushing off to the end of the screen and I wouldn't have room for my arrow. So one, just a logistical reason for the slide. But two, we're at the point in the semester where I can start showing more advanced stuff in Scala. So this BT node takes a type parameter A. So when I create a BT node, the first constructor parameter has to be of type A. So what Scala is going to do is infer the type parameter and say, okay, you're calling this constructor and you gave me a string. I can figure out that you mean A to be string, and I don't need you to explicitly tell me that A is string, the type parameter is string. So it's going to say, okay, you're creating a new BT node of string. This is a new BT node of type string, and then you're assigning it to this variable root. So root must be a variable of type BT node of string. So it's inferring all of that. You can be explicit. You can say right here, colon, BT node of string. You can right here put the string type parameter, and it'll be the same exact functionality. But here I'm using Scala's type inference. This still compiles, it still runs, everything's fine with this code. Scala's got my back on this and says, I know you meant string because you gave me a string. And then everything's all good. So this is creating a BT node of day, null, null. So left and right references are both null. They don't refer to any nodes. And we're going to create a new BT node with the value have, null, and null. So we get a new node on the heap. And we're going to set that equal to root.left. So root.left, which was null. We had this null as a placeholder. Now we're replacing that with a reference to another node. So we replace that with a reference to this node that we created with the value have. Same thing with the right. We're going to create another new node, constructor call, node on the heap. This is a reference to the object that was created, and we return, what this resolves to is, what the constructor returns, is a reference to the node that was created. So we return this reference 480 to wherever we're returning to, which is root.right, and replace that null with 480. So we had two nulls on the root node that were both placeholders, and then we replaced both of them with references to actual nodes. So we have the root node, day, and then left and right child, having those nodes there. So even though we created this with null and null, we've replaced both of these nulls with references to actual nodes. And again. So we create a fourth node, the value a, null, null, and set that equal to root.right.left. Root.right.left, and replace that null with 936. So this is how, visually, this is what's happening in memory. This is how we're building the tree. So it can be confusing the first time you see my root.left equals root.right, root.right.left. It can be confusing at first, but this hopefully clears that up. This is the visualization of everything that's happening with the constructor calls, what's happening on the heap, and what's happening with these references. So with a tree, and the same is true with linked lists, we have all these nodes just scattered wherever in memory. We don't care where they are. These numbers can be vastly different from node to node, these references, and that's fine because we're linking all of these nodes together through the references. So our root, which we would think of as our entire tree, is just a reference to a node. That's all it is. And then through these references, through having the left and right references point to other locations in memory, we create the illusion of an entire tree. Same is true with our linked lists. When you have a Scala list, you create a list variable, you set it equal to a new list. You think of that variable storing a list, which is how we use it. We have the illusion of that, and it's a pretty strong illusion that's the way we use it. But in reality, we have a reference to the head of the linked list, the first node in the linked list. And then all the methods that we call on that, Scala is going to navigate the list by following references from node to node until it sees null, and then that's how we use the actual linked list. But we only have a reference to one single node, and then we use the references, follow references, hop around memory to be able to create the illusion of a data structure. All right, any questions on the structure of the tree? The rest of this is going to be the traversal. And first time we went over traversals, it might have been asked in the other lecture, maybe in this one, I don't remember. But I had this tree with 7 nodes that we've been using for the last 2 lectures. And the question came up of, you're not going to make us do this on the quiz, are you? We're going to have tons of stack frames. Most of them will just be null and not do anything. But it's going to be a lot of clutter on the memory diagram. And I agree, and I'm not going to do that to you. But a tree with 4 nodes, I'd say that's fair game for the quiz. 4 nodes is that perfect number where we at least get down 2 layers, but without having so much tedious work that you're just doing tons of stack frames. So you can expect probably a tree with 4 nodes on the quiz. And this is small enough that it's going to fit on the slide. We will get to the bottom here with stack frames, but it's small enough that we're going to fit everything on here. So let's do a traversal. So we're going to call traversal with root, which is this node at 350. This node is not null, so we don't hit our base case, and we're going to start running the code inside this conditional. So we have the very first thing we do, traversal of node.left. In this stack frame, node.left, that's the node 200. So we're going to get another recursive call on the stack of traversal where node is this node at 200. This node is not null, so it's going to call traversal of node.left. Node.left is null, so we're going to get a call of traversal, a recursive call of traversal on null. And I'm not going to draw my nulls unless they're relevant to what we're currently doing. This time it's relevant, so we have this null here, but really we have null here, 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 and here as well. But we have null right here. We get traversal of null. This is our base case, so it just returns. It goes back up to this stack frame. So this stack frame returns, and we can start seeing the structure of the stack. The stack is going to be more relevant. Well, it's always relevant, but we're going to be able to see a little more complexity with it today. So we have the main stack frame on the stack, and then on top of that, this root recursive call, and then the root's left recursive call, and then we had another stack frame for null. So we got 4 frames on the stack. Remember, it's a stack. We can only add frames to the top of the stack and remove frames from the top of the stack. And again, we visualize it going down. The stack's going down. So the bottom of the slide is the top of the stack. But when we remove this frame from the stack, this frame returns, execution goes back to the next stack frame that hasn't been destroyed. So we remove that and go right back to this stack frame. Because the question is, well, would we go to this one? Would we go to the main? We go to the next one visually. You just go up your memory diagram. The next one that you haven't crossed out, that becomes the active frame again. So this node, we have 200. So we're looking at this node. And we can look at our pointer here to see where we are in the execution of this stack frame. And each stack frame, this is going to be the big point for this lecture, each stack frame remembers where it was when it gets its execution back. When it gets control back of the program, it remembers where it was. This stack frame just called traversal of node.left. It remembered that that's what it was waiting for. It got its return, that stack frame returned. It didn't return anything, it returns unit, but that stack frame's done. This stack frame gets control again, and it moves on with the code. Moves on to the next thing, which is making the recursive call to its right child. So the next thing it's going to do is make the recursive call to its right child. We're going to add that to the stack. Its right child is null. Add that to the stack. Base case doesn't do anything. Returns, and returns back to this frame again. And this frame again remembers where it was. So this frame was waiting for this call to finish. That call's done. So it's going to go to the next line of code, print its value to the screen, and then be done. Prints its value to the screen, done, returns, and gives control back to the next stack frame on the stack. So we're back to this stack frame, which again remembers where it was. It remembers that it just made its left recursive call. So it's going to move on to the right recursive call and put a new frame on the stack for its right child. So we get this as node, this node at 480. That node is going to make its left recursive call. Dot left. This node, still not null. It's going to make its left recursive call, which is null. Node dot left. which is null and just returns. This node remembers where it was and makes its right recursive call, which is null, which won't do anything. But here I want to take a time out and take a look at what's going on in memory right now. This is as complex as this example is going to get, so I want to pause right here for a bit and talk about what this snapshot in memory means. So like if I set a breakpoint and ran the debugger and stopped it right at this point where this stack frame is active, this is what we would see in the debugger. So let's talk about what we're seeing. So we have this, well, we have the main stack frame, which has been sitting right here for this call to return for quite a while, the whole memory diagram, except building the tree. That called this stack frame, which is looking at the root, what we think of as the root node. It's just an illusion. But looking at this node, and it's sitting right here. So we have, this is the lightest gray arrow. This arrow is pointing right here, waiting for its right recursive call to return. And this is how stack frames actually work. In memory, these stack frames are going to remember where they are. They're going to have a program pointer which is going to remember which line of code they're executing, and they're going to sit right there waiting and remembering that. So when they do get control again, they're going to look at that pointer and say, okay, where was I? Oh, I was on this line? Okay, when I get control again, I'm going to go on to the next line. They're actually going to, the stack frames actually remember that in memory. That stack frame called this one 480, which is this node great, which is the medium gray arrow here, which is waiting for its left recursive call to return. So when it gets control again, the next thing it'll do is make its right recursive call. It's waiting on this stack frame with great, this stack frame with A, the dark gray arrow, which is currently making its right recursive call. Then finally we have this stack frame with null, which is the base case, which isn't doing anything. So we have 4 recursive stack frames, most of which are waiting at different points in the execution of this code. And when they get control back again, they have to remember where that specific stack frame was and then pick up its execution right there. This is what recursion is doing for us. Recursion is doing a lot of work for us, a lot of this bookkeeping work. So when I have my challenge of rewrite one of these traversals without using recursion, I am happy to say that somebody did take me up on that challenge. So a student finally wrote it without recursion. It's over 100 lines of code, but they did do all 3 traversals. Over 100 lines of code to do it instead of like 15, 20 with recursion. And to do that, so I can no longer, next semester I won't be able to say, nobody's ever taken me up on this. Finally, somebody accepted my challenge. I'm happy about it. But when you don't use recursion, what this student did was remembering all of this information, all this bookkeeping. So they have a stack to simulate the call stack, which is going to be a stack of nodes, which is what nodes still need to be processed and which nodes are done. And each node we're going to visit 3 times, if it's not the base case. If it's the base case, we only visit it once. If it's null, we just don't do anything. But if it's not null, the first time we visit it, it makes the left recursive call. The second time we visit it, we make the right recursive call. And the third time we visit it, we print and pop that off of the stack. So we're going to add nodes to the stack and visit them 3 times before popping them off the stack. And we have to remember which visit it is. Each time a node makes it back to the top of the stack, is it the first, second, or third visit? And that's going to determine what we're going to do. They're going to add a new node to the stack and move to that node, or print and then return, pop that node off of the stack. So all this bookkeeping has to happen in your code if you're not using recursion. So the student had a stack, the concept of a stack, again, not a literal stack. They used a list, following my advice, and had a stack of these nodes, and then a data structure. I believe they used a map to map nodes to number of visits, and then checked each time a node was at the top of the stack. Check how many times they visited that node. That informs what to do, whether to put the left child on the stack, pop the left child onto the stack, push the left child onto the stack, push the right child onto the stack, or print and pop that node off of the stack. Those are the three things. Depending on the visit number, do one of those three things, and then either increment the visit number, or if it's the last visit, you're done with that node anyway, so it doesn't matter what that number is anymore. Or you use recursion and let the stack in stack frames take care of all that bookkeeping for you. Makes things a lot simpler in this case because we're leveraging the information that the stack keeps track of in the stack frames, namely each stack frame remembering where they are in this execution. And the literal stack data structure, the concept of a stack data structure being a stack of stack frames, which remembers which node to return to once we're done visiting a particular node. Okay, any other questions at this point? Because the rest of this is downhill. It's all stuff that we've already seen earlier in this example. Okay, let's do it. Node of null returns, gets control back here. It remembers it was on the right recursive call, so it moves on to printing, prints and returns. Gives control back to this stack frame. This stack frame is going to make its right recursive call because it was waiting on its left recursive call. Right recursive call is null. Oops, make the recursive call. This is null, which doesn't do anything and just returns. We were waiting on the right recursive call. The next thing to do is print and return. Now, when this stack frame returns, we can see the structure of the stack a little bit more. We're going to return back up to this stack frame. It's the next frame on the stack that hasn't been removed, that hasn't been destroyed. So we're going to go all the way back up to this stack frame after printing. This stack frame was waiting on the right recursive call. It's going to print and return. And go all the way back up to the main stack frame, which was waiting on this call of traversal. Everything's done. We got everything printed, and the program ends. So we stopped at the most complex point, and then it's all downhill from there. It's easy to get all the way home from that spot. Any questions on that? Everyone good for tree memory diagrams on the quiz for LO3? Which will be when we get back from break. Okay. And even with 20 minutes of intro, we have time to go through these slides. This memory diagram wasn't too bad in terms of presenting. There's a lot of complexity going on, but in terms of presenting it doesn't take too long. I said everything I need to say, waited for questions a while, so we done. We'll just end a little early today. So have a great day. I'll see y'all Monday.